So let's say we have a situation where we have two equations for waves. y1 equals 0.02 times cosine of 4x, and y2 equals 0.03 times cosine of 4x. And the first thing we're asked about these waves are they in phase? So how do we answer this question of in phase or out of phase? So if a wave is going to be in phase with another wave, that means that their deltas, the little delta symbol, has to be equal to 0 for both the waves, or some fraction of 2 pi, some multiple of 2 pi. So I could do another wave. I could do a y3 here. I could say my y3 is equal to 0.04 times cosine of 4x plus 2 pi. And each one of these waves is in phase with the other waves that are listed, because all their deltas are either equal to 0 or 2 pi away from each other. Okay, so these are all in phase waves because their deltas are 0 or 2 pi. Now that we know that these waves are in phase, we can do more things with them. We can add them together. We can add their amplitudes. And only because they're exactly in phase are we able to actually just add the amplitudes. So the total amplitude of, say, adding y1 plus y2, our amplitude will equal to the sum of both of those amplitudes. So the amplitude of y1 is 0.02 plus the amplitude of y2, which is 0.03, would give us a total amplitude of 0.05. And again, that is only able to happen because these waves are completely in phase with each other. We could get a different kind of situation. We could get a situation where we have two waves that are completely out of phase. So let's write an equation. Y4 equals 0.02 times cosine of 4x minus a pi. And here we see we don't have the same phase because the delta that we have in y1 is a delta of 0. The delta we have for y4 is a delta of pi. And since these deltas aren't different by either 0 or 2 pi, that means that they're going to be out of phase. And it turns out that if they're different by a fraction of pi, by some multiple of pi, then these are completely out of phase. So y1 and y4 would be out of phase. And they're exactly out of phase by 180 degrees. So since these two waves are completely out of phase, we can find their amplitude too. That's going to have a peak of one of the waves is going to be a trough of the other. So while we have a positive amplitude for one of the waves, we're going to have a negative amplitude for another wave. So I can see y1 has this positive amplitude of 0.02, and at the same time that we have a positive amplitude there, y4 is going to give us a negative amplitude of negative 0.02, and we'd get a total amplitude of 0, and these two waves would cancel each other out. Again, we can predict this because we know these guys are completely out of phase because their deltas are different by a variable of pi, by some multiple of pi. And then the final thing we could ask about these waves is what are their individual wavelengths? So because each of these waves has the same k number, they each have that k wave number equal to 4, they all have the same wavelength. So that makes this question actually doable. Without them having the same wavelength, this question would not be possible based on what I'm going to require you to know. So we don't have to worry about that situation. All we need to know is k is equal to 4, and since both waves have a wave number equal to 4, we can actually find the wavelength of these two waves. And we know in general k is described as the wave number which is equal to 2 pi divided by lambda. So 2 pi divided by lambda in this particular problem is going to be equal to 4. And I can do some algebra to shuffle this around and find that lambda is going to be equal to 2 pi divided by 4. And when I plug that into my calculator, I can get my final answer. I can find that my lambda, when I plug in 2 times pi and divide it by 4, is going to be equal to 1.6 meters. So that's just a simple little example of some of the kinds of questions you could be asked about in terms of waves and how they add together when they're in phase or maybe when they're out of phase.